Hi, folks. We'll get started here, and thanks for joining us today. I'm assuming people are going to continue to come in, but we'll get started. Just an FYI, this webinar is recorded. And in today's webinar, we'll be talking with H2O AI, and here's the agenda for the day. We'll start with some introductions of the speakers, and then we'll talk about how AWS is democratizing the AI revolution. We then delve into how AWS and H2O AI are working together to bring GenAI workloads to the cloud. We'll go into the main topic of the day, which is fraud detection. Then we'll show you a demo of the fraud detection use case, followed by Q&A and a call for action. During the webinar, if you have any questions, please post them in the chat session. We'll get to them either synchronously or asynchronously throughout the webinar. So let's get started with some introductions. My name is Art Siddiqui, and I'm a solutions architect with AWS, focusing on GenAI partners and GenAI workload on AWS. And my colleague, Asghar, go ahead.
Yep. Hello, everyone. My name is Asghar Rabbani. I'm a lead data science at H2O with nearly a decade of experience in data science field. I have had the privilege of working actually on a diverse range of projects across various industries. So I'm also thrilled today to be here together with my dear friend Art from AWS, and really excited to share my insights with you in this webinar.
Thank you.
Back to you, Art.
Thank you. So at AWS, we are innovating on behalf of our customers to deliver the broadest and deepest set of machine learning capabilities for builders of all levels of experience, removing the undifferentiated heavy lifting so that our customers can move faster. Over the past 5 years, we've been investing in our own silicon to push the envelope on performance and price performance for demanding workloads like ML training and inference. Our AWS Trainium and AWS Inferentia chips offer the lowest cost for training models and running inference in the cloud. This ability to maximize performance and control costs is why leading startups such as H2O AI runs on AWS. As you start to think about the future when you need to train and deploy models at scale in your applications across your organization, most costs will be associated with running the models and doing inference. A production application can constantly be generating predictions, potentially generating millions per hour. Inferentia 2 instances deliver up to 4x higher throughput and up to 10x lower latency compared to the prior generations of Inferentia-based instances. These capabilities deliver up to 40% better inference price performance than other comparable Amazon EC2 instances, and the lowest cost for inference in the cloud. In addition to custom silicon, AWS offers a broad range of ML frameworks and AI services. Expert practitioners can develop in the framework of their choice. Data scientists can use end-to-end capabilities of SageMaker. Business analysts can build their own model using Canvas, or application developers with no ML skills can add intelligence to their application using pre-trained models offered as managed services. We have a number of these managed services. You can see these in top of the picture. The title is the AWS AI services. With AWS, you can innovate faster with the most comprehensive set of AI ML services. Let's talk about 4 key areas where AWS is helping to deliver that level of innovation. First, AWS enables AI-powered use cases with hundreds of pre-built algorithms, models, and solutions for common use cases and industries, and delivers faster time to value with 23 pre-trained services like Amazon Personalize, Amazon Kindra, and Amazon Monitron. Secondly, at AWS, we are working to democratize access to ML and make ML accessible to more people. Amazon SageMaker Canvas empowers any business analyst to make predictions without writing any code. And with AWS AI services, you can easily add AI capabilities to your applications with no ML skills required. Third, you can easily scale ML with AWS. Amazon SageMaker allows you to build, train, and deploy ML models for any use case. And as we continue to see the exponential increase in the sophistication of ML models with an increasing number of parameters, you can build your own or access open source foundational models on AWS through Amazon SageMaker. And last, we're committed to helping you grow your ML skills at your organization and educating the next generation of ML developers with a whole host of resources from AWS training, AWS Deep Racer, to our AI and ML scholarship program, and AWS Machine Learning University. You can also further accelerate your journey with AWS ML Embark and AWS ML Solutions Lab. Amazon has been investing and using ML for the past 20 years for recommendations, personalizations, Alexa, and many more. We have some of the most sophisticated ML deployments in productions. Over the years, we have helped more than 100,000 customers achieve their ML success. These are, again, some of the reasons why H2O utilizes AWS for their platform. So I wanted to take a moment and talk about our partnership with H2O.ai. H2O has been an AWS technology partner for 4 years. They also have been an ML competency launch partner with us. H2O driverless AI allows you to build production-ready machine learning models in hours or days, not weeks or months. Driverless AI is designed to work with AWS to maximize its machine learning performance. Using H2O driverless AI, organizations with little data science experience can quickly create advanced machine learning models, including typically difficult and time-consuming tasks such as feature engineering, model tuning, and stacking. This fully managed enterprise-grade machine learning and GenAI platform runs on AWS and is available on the AWS Marketplace. Today, we are going to show you the technology integration between H2O and AWS, which you can leverage for different use cases. The use case we're focusing on today is fraud detection, which is a critical use case for financial services institutions. With that, I will hand over to my H2O AI colleague, Asghar, to talk more about the H2O and the fraud detection use case.
Okay, thanks, Art. Well, as pointed out by Art, in today's webinar, we will be exploring the integration of H2O is award-winning autoML tool, basically driverless AI with AWS and its benefits through the lens of fraud detection use case. So fraud detection is an interesting and intriguing use case, at least from two perspectives. The first one that I like to mention is the fraud detection is really challenging problem to solve, particularly because of the environment in which these models need to operate. Let's take a look at a few constraints and challenges for fraud detection application that we face. The first issue that I'd like to raise is that the current system suffers from high levels of false positives or false alarms. I'll come to that a bit later. The other thing that I like to mention is that the fraudsters constantly develop a new evasion techniques, so the fraud patterns are changing in time. I don't think that we need to consider always is a balancing security with user experience. So intense verification and false alarms basically negatively impact user experience. On the other hand, determining really what data do we need to collect and how you're going to use this data, the stuff data that we are collecting is a crucial part of the process. Imagine, we want to piece together the customer's behavioral pattern. If you want to do this really accurately, so we need to, first of all, collect a diverse type of data set, and our solution needs to handle that complex data points. This system needs to run near real time and adhere to regulation and compliance. They need to adapt to new technologies, such as new payment method like cryptocurrency or mobile payments, while still being able to use or work with legacy systems. And after considering all these constraints and challenges, still we expect this system to be very accurate. And the other thing that I like to hear emphasis again is that we are not dealing with a static environment. Things like fraud pattern, customer behavior, technology, and so on and so forth, constantly changing all the time. So any solution to fraud detection needs to be able to cope with this dynamic. And for this, whatever solution that we come up with for fraud detection, one thing that they need to definitely have is that they need to reduce friction to build a model and to deployment, so that we can frequently deploy, a new model as things change. So what I want to say here is that it's not really one-time job. So we need to refresh this model frequently due to these changes. And this is where actually this joint work with AWS comes into play, and so it becomes really crucial. With H2O, we can build the most accurate model through autoML. And by integrating with AWS, we can deploy these models swiftly and seamlessly, while benefiting from AWS security and compliance standards that is already in place and you might be using. The other thing that I wanted to mention about fraud is from a financial perspective. The financial impact of fraud is really significant, and it's increasing every year. And the interesting number here is that it makes up about 6% of world's total GDP. So to put this into perspective, that's more than the entire economy of Germany or Japan. So if fraudster were a country, they would have one of the largest economy in the world. So actually third economy in the world, if all were in one country. So yes, in previous slide we saw that the fraud detection is a complex problem to solve, but absolutely it's worthwhile to pay attention to it due to the financial significance that it has. So what has been done so far to address this problem? Perhaps this slide sort of summarizes what has been done. The surprising fact is inefficiency of current approaches. And we're going to come to that and why that's the case. So the problem now is that we're spending 3 times more trying to stop fraud than what fraud actually would cost. So, you put it in another word, in our effort to solve already a big problem, we have created even a bigger one. But the good news is we have evidence by working with our customers. If we approach this problem effectively, we can recover a good portion of these costs that imposed on us. So, for example, here Andy Marcus, a CDO at AT&T, explaining how they use H2O to build machine learning models to combat fraud, which led to recovery of somewhere around 1.5 billion US dollars. So I will elaborate that a bit later, how things work for them. But before that, first I'd like to spend a few moments and discuss current prevalent approach that we actually know most of the places used, which is based on a rule-based system. So how these systems work, so they're based on sort of rules, like, if you take a simple example, when you use your credit card, for example, there are a set of questions and checks will be done, like, is the card physically present? Where did the transaction take place? How far apart were the last two transactions, for example? And if the answer to this question is like, if the last two transactions with card present occurred miles apart in a short period, that would be very difficult to travel that distance. That obviously is an indication for fraud. So that's sort of in a nutshell how these rule-based system work. Rule-based system are one of the reasons that why we like them is that because they're really fast, so they're a set of rules can be checked quickly, and they're transparent, so we know what the rules has been implemented, right? So it's clear, transparent, so it's very fitting very well in regulated industry, but they are limited in scope. And what I mean with that is that the number of data points they use to create these rules are typically very limited. Like, they are limited to geography, transaction amount, the frequency of transaction for with merchant or for customers. So these are typical data points that are used, and obviously if we use more data point, we're going to more accurately detect the fraud pattern. There has been research that basically validated. Obviously we don't need a research to say that if we use more data point, we are going to be to the key. But these aspect that if we use more data points, how it's been reducing fraud, the fraud or false positives, have been formally studied. So the other issue with this system are that they're really they're not that flexible in responding to changes. So what it means if that what I mean with that is that if, for example, a new fraud type emerges, what happens is that fraud analysts need to go and manually analyze those fraud types and come up with a set of rules that are going to prevent that. And this rules needs to go through the approval process and then implement it, which that really a very lengthy process. As a result, even if you are coming up with a good rule, we are always behind new trends in fraud. So now that we know, what typical fraud detection system works, which is basically based on rule-based, I'd like to come back again to this AT&T case. Again, as I mentioned, the default mode for many fraud detection systems, including AT&T's a few years ago, is these rule-based engines. So what we see in this slide, and I want to show, is the 3-year journey for AT&T, how they have overhauled their fraud detection system. Each line represents rate of undetected fraud within a single year. So initially, AT&T used rule-based like others to combat fraud, which is represented by this blue line here on the top. So we see that the rate is very high and relatively constant. There's an up and down, but relatively high and constant on average. But in the second year here, we see that each point here represents a new model that goes in production. And what we see here, as more models go into production, the rate of fraud that goes undetected drops significantly. And at the end of third year, they have been able to reaching 80% reduction in fraud cases. So which result approximately to 1.5 billion US dollar, as I mentioned earlier. So basically what this demonstrates is the benefit of using machine learning solution in real world scenarios. So what I'm going to do next is sort of work a couple of approaches in machine learning that we can use for fraud detection. The specific example that I'm going to use is from a real customer for building fraud for credit card transactions. And so this customer is a large financial institution having daily a huge number of transactions. As mentioned a couple of times, again, most of the transaction that has been flagged in their current system at that time that was flagged as fraud actually was not fraud, like again, high false positive rates. So what they wanted to do is twofold, reducing fraud, obviously, and then at the same time reducing the false positive rates that their system had. So what I'm going to do now and walk you through through the major class of models that we have built together to address these problems that they had. So what I'm going to show here is in a sketch of basically a simplified overview of how these transaction monitoring systems work. For example, when you swipe a credit card or use your phone or a smartwatch to pay or purchase something, the transaction is processed through this rule-based engines similar to one that we discussed earlier, and that was the same for this specific customer. And so what they do is, again, these engines evaluate the transaction based on this set criteria, and it passes, then it goes through, and if not, it raises alert, it goes through review by a human expert, typically the fraud analyst. So again, we have mentioned this earlier, due to limited accuracy, obviously not all the transactions that go through are legitimate. So there are a certain number of frauds that go through despite this fraud detection system. On the contrary, if what we see here, so just a quick one, the red are fraud, and the green part here is basically the legitimate transactions. So for this one on the top, ideally, we don't want to see any red. So whatever the rule passes is sort of legitimate transaction. The one on the bottom, so what we expect is that when this rule-based engine gives us an alert, we ideally want that to be actually true and not a legitimate transaction. So this green part here is false alarm. So if you look at the number, so this is the number for entire in the US, not for that customer, but the rates were very close to that figure. What we see here, the credit cost fraud in the US is around 9 billion. But the cost of false alarm, we mentioned earlier, on average 3 times higher. But here in this case, for credit card, is actually more than 10 times the cost of the fraud. So obviously, the bigger problem here, at least from cost point of view, is false alarm. So again, what we wanted to do, and the typical solution here is again is twofold. We want to reduce that red one here and the green one here, reducing false alarm. And if cost is actually an important point, obviously we need to start from this part, because that's really bigger, much bigger problem, and that was also for the customer. So the way that we did it is as following. So imagine that you have, again, this system similar to here. What we did, we put a machine learning model in front of the route that goes these alerted cases. So how we build this is interesting. If you look at what these, a human expert like fraud analyst is doing, what they've been doing in the past, they were generating labeled data for machine learning. So what they do, whenever that these engines say that, okay, this is an alert, they will analyze and label that whether that was a false alarm or it was actually fraud. So now we can use this data to build these sort of models here. And by doing that, so when we train a model using this labeled data, we can classify transactions with high likelihood of being false positive, and allowing those transactions to be redirected again and go through. So that model basically handles this part. And for the cases that goes through and we don't, like these engines don't identify, at least for the reported one, we can use another model here using the reports for the cases that gets identified and gets labeled that it was fraud. We can use that data set to build this sort of problem. The one problem obviously is with this rule-based engine I mentioned earlier is that the limited data points that is being used by this engines. But now that we can use machine learning, actually we can utilize autoML to automatically run this feature engineering. So as a result, we can ingest any number of data points that we like and allow the machine learning tool to decide which of these data points is relevant and what data transformation is required to create really a strong model that can detect these cases. And obviously there are other cases, such as like the unidentified cases. So these cases, gets never reported. So we don't have an example of it to build a supervised model. So for this type of problem, we need to build a sort of different class of models that's called unsupervised, and in this specific case, anomaly detection models. So the way that they work by adding anomaly detection. So what they do, they pinpoint transaction and behaviors that deviate from the norm. And by doing so, we can use that signal as another indicator whether that's fraud or not. So the advantage of this is, again, is that we don't need labeled data. We can just start with our data and build model to detect those sort of issues. So one interesting aspect, okay, what we have been doing here is that we are building various types of models to cover the drawbacks of these rule-based engine. We are not replacing that. So this is a very important point because, for regulatory purposes and compliance, we still need to use that. But what we are doing here, enhancing rule-based engine system. So there are, of course, there was always discussion where we said, okay, no, we could use AI to enhance the system. People are typically, a bit, I'd say skeptical because they said, okay, we cannot get rid of this rule-based engine due to many reasons, and many of them are actually good reason. But what we are doing again here, we're just enhancing the system with additional defense layer rather than replacing those existing solutions. So now it's time to feed things a bit in more practical terms. So I'd like to demonstrate how to build such models using H2O's autoML tool and deploy them in SageMaker. So the pipeline that I'm going to follow is this one. So I'm going to start with training model, and then we're going to see how we can push into Amazon's container registry, ECR. And from there, we are deploying SageMaker. And as soon as we have a model here for inference, we can use various tools to sort of do the inference that we need. So let's, I'm going to start with this part, training first. And for this, I assume that we already have the data set, the label data set we need to build the model. So I'm going to switch to H2O.ai class. So obviously first I need to log in H2O.ai class. That H2O.ai class is a platform that we can get access to various data science tools, and it actually runs on AWS. It doesn't have to run on AWS. You can run it on-prem or whatever that suits you. Still, we can connect to AWS and push our model and deploy in SageMaker. So in order to deploy in SageMaker, we don't have to run at AWS again. So the tool that we are going to use today, as mentioned a couple of times, is AWS AI. So that's our autoML tool that automates the model building process, essentially. I have already opened up one, so I'm going to start from here. So what we see here is the user interface of AWS AI, and these are the data set I've already uploaded. So we can connect to various data sources in AWS to load it into AWS AI with it, but I'm not going to bore you with connectors and things like this today. So let's have a quick look at what data set we have. So this is a data set, so typical sort of transaction data, obviously limited in real case, depending on your system, what your story, you might have a totally different sort of data set. But what we got here is customer data, merchant information, and some historical information about transactions. And what we got, which is important, is this label. So this label, again, depending on what type of model we are building, it'd be different. In this case, just actual fraud. So in general, if the transaction was fraudulent or not. But this could be one of those labels that fraud analysts generate, whether it was a false positive or not. So we could use, in that case, that label. So anyway, so what I'm going to do now, build a model, and building model using AWS AI is really straightforward. Don't think that I need to do here, select the data set and then hit predict. From there, I can select in the label. So I'm not, the only thing that I need to do here is say that, okay, this is the label I have. So with that, all the necessary settings will be done by AWS AI. So I don't need to do anything more than that. And by hitting launch experiment, AWS AI starts building, various types of modeling techniques and trying out different data transformation and combination of those transformations to figure out which of these really work best for this specific use case. If you have expert data scientists and expert users, they can obviously access and go under the hood to expert setting and change anything that they want, basically, to have full control of what's going on during the pipeline and model building process. So it's not a closed system. It's obviously, it allows you to do whatever you want through the settings, and also that allows you to upload your own code. So if you have a specific code for feature transformation, if you have a specific code for modeling, you can import that and make it part of the mix. And you can also see at the end whether your model worked better or the model that comes out of box. That's one thing that I want to mention. The other thing that I'd like to mention, the one class of modeling technique that we talked about was anomaly detection, the case that we don't have label. In that case, I need to select unsupervised and then select the unsupervised technique, which in this case would be anomaly detection. So I select, for example, isolation virus anomaly, and I can build the model for that sort of case. But today, what we're going to focus was that is supervised for fraud. So if I launch experiment, again, as I said, it just JAWS will start building models, but I'm not going to do that because it's going to take some time. I'm switching to the one that I already did it, and the experiment is finished already. So what we see here is finished experiment. So what, again, has been done here, all the processes that I mentioned earlier, like, model building, we can all see that what type of algorithm, every step has been tried, and what data transformation has been done and which ones really were very important is sort of listed here. And one thing that I would like to call out is this number here. What we see here, what AWS AI did, more than 500 different ways of data transformation and combination of those, and built close to 200 models in just 70 minutes to figure out, okay, what modeling technique is useful, what combination of those features and transformation is useful. I'm conscious that in a regulated industry, you might be, a bit We need to be conservative whatever what we do, what data transformation we do. We cannot try everything. So these think that the level of what level we are okay to do these kind of transformation. We don't want to end up a crazy transformation that we cannot implement in regulated cases. So we can play out with the settings. For example, interpretability if it's important, I can dial up, and then the sophistication will be reduced. The accuracy might be impacted. But then we can control really, how we want to build our model. So that's one thing. So now that we have our model, we can, sorry, but now that we have our model, we can go and deploy it. But before we deploy, I'd like to mention two things. One is, okay, one thing that we again need here is the transparency. So we want to be able to explain what has happened on the node. So there are a lot of things has happened. We see that close to 200 models has been built. There are two ways that we can get access to this information. One is downloading a document like this one. So what we see here is a document that are automatically generated and describes everything and most important details that we need to know about what has happened on the during the process of this experimentation. So like what type of feature engineering has been done, data transformation, and model tuning, evaluation techniques, and we see some of the evaluation charts here as well. So that these information which allows us sort of use that as a reference for our model validation process or model approval process if we have internally. The other thing that we have, and unfortunately I won't get the time to go into this into detail, another important topic in when we build models is called machine learning interpretability, MLI, which basically describes us why models do certain predictions in certain ways. So for example, if model says that the likelihood of being a transaction being fraudulent, if you only get that information, there's a lot of cases that's not sufficient, because if someone, so we need to be able, and especially again in regulated industries, we need to be able to answer questions like why this transaction is fraudulent if the model. So we cannot respond to now that be because model said so. We need to be able to explain why based on the input data, or actually based on the transaction characteristics, like whether that's the payment or the certain merchant says certain behavior. So what we can do here is when we deploy, we can ask them endpoint not only deliver us the likelihood, but what characteristic with input data basically drives the likelihood up or down. So based on that, we can sort of explain why the model thinks that this certain transaction is fraudulent or not, and that information also helps fraud analysts when they review flag transactions. Based on this information, they can speed up the review process that they do. So now I'd like to get to the next step, basically, which is deploy. So now that what we did here is sort of we saw how we can build models using driverless AI. The next step obviously is to take the model, and what we need to do here before we deploy in SageMaker, we need to containerize it and push it into ECR. So let's look at how we can. Okay, one thing that I want to mention before we go into that is, so what I did now, I showed you through the UI how we can build these models. If we want to automate that or put that into our building model pipeline, we can use build the model, and all these things that needs to be done that I did it through the UI can be done programmatically as well, so that we can automate that process. So for this step, I'm going to use eScorer. among other things, what Score does is automatically generates the script artifacts that I need to deploy these models in various environments. So now this fraud detection model that I've built, so I can select a model here and say that now what I want to do. So I've already selected it, but I can select depending on what stage I am, what I want to do. I can select the artifact that I need, and here hit generate, which in this case is a container for SageMaker, right? So if I hit generate, what it does for me, it would, okay, it's refreshed session. Just let me select again, fraud detection, the container, so generate. So what I'm supposed to get now is a Docker file that I can download and build the image that I need for this specific model. So when I have this Docker file, the next thing that I need to do is build the image and push it in ECR. So for that, what I need to do is like the SageMaker commands, and here it gives me the set of commands that I need. So now I can run this in command line, or again, integrate with my automation pipeline if I have one to do that for me. So as soon as I run this, I will have my image ready in ECR. So I'm not going to run this command, so it's going to take some time for saving a bit of time. I've already done it before, so these are like ready to use images in ECR. Okay, let's go to the next. Okay, I'm gonna skip this one. So as soon as we have our image in ECR, the next thing that we need to do is deploying it in SageMaker. I'm going to do it again. I'll go to eScore and say that I want to deploy it. And what I can do now here is selecting, okay, we've got here deployment using a notebook. So now I can generate a notebook and run it in SageMaker Studio. So I can download it. I did it already. So here in SageMaker Studio, I can start a notebook instance. And if I upload this one, I will get something like this that you see here. All has been created already. I don't need to know. Obviously, eventually I will know how to use SageMaker. Otherwise, it doesn't make sense for me to deploy it. But basically, what I might say that is that this script's already ready, so I don't need to know how to call it exactly, or what parameters I need to set. So everything preset based on this model, but still I can change if I need it, and put that also as part of pipeline if I again want to automate everything. So I need to provide the location where the image is. And then, if you're familiar with SageMaker, we need to first create the model definition and confirm the hosting endpoint. And from there, we can create endpoints. So all these steps will be automatically generated for SageMaker. So as you can see, I've already run this again so that we can save a bit of time. And as soon as everything's finished, you can go here in SageMaker, in inference, in endpoint. If you hit here, you'll see your endpoints in this list that, as you can see, I've already done it 2 times. And as soon as the service in service status, I can start using. So how now can I use that endpoint? Again, I can go to eScore and get an example for this specific model, how I can use this model after it's deployed in Score. So I get something similar to this that I can just simply hit here and run and get the prediction. And okay, this one maybe not was not correct, but it doesn't matter. Let's run the other endpoint. Maybe I was not using the right endpoint here. Okay, yeah, that was the correct one. So as you can see, it returned again 20% likelihood of this transaction being fraud with this information that I put here. So I can change these and see how that impacts the likelihood of fraud. So in this case, it's like 20%. I would say it's relatively high. And that's also a good point. That's criteria where we set what is the what probability we are going to say that that's fraud, and we are going to reject that transaction. That's really a good parameter, because these models is not in contrast to rule-based engines, we only say like it's fraud or not. What we get here is likelihood. So what is the it's like 20% probability of that being fraud. Is that high or not? Depends on various things. Depends on how. What is the appetite of risk for me? What is the cost of false positive? So I can consider all these points and actually optimize where I'm going to put that criteria, and whether if it's based on cost saving. So I can see which criteria is basically the optimum point to save most of the where I get the most of the saving. Anyway, so now we saw that, what is the process to come to that point. Now I've deployed it, I can simply use it. And I can use, through the example that we saw through the Jupyter Notebook, or what I can do now that I have that input available, connect other tools in AWS ecosystem, like Redshift, to use that endpoint seamlessly to do the inference. So let's look at again an example. For any tools that you might have, again, question how I'm for example, a question like this, how I'm going to connect Redshift to Amazon. So we have simplified all this again with eScore. So I can go in here and say that, okay, I need to connect to Redshift. So it will generate everything that I need to do that in Redshift. So one step is to create a function. And as soon as I've created a function, and this function will have access to SageMaker, then I can use a typical SQL statement like select to get this prediction. So I've done this already. Let's go here. Okay, that's my database in Redshift. As you can see, I've already created these two databases. So I don't run this to create the function that I need. And after I have the function, then the rest would be just this simple sort of SQL call. Again, if you need to know how to use this endpoint, it will generate for you for that specific model. Because some of the time, the model might drop certain columns and don't use a certain inputs at all because it doesn't add any value. So you don't need to, look at the models to what columns, should be go into the model, what not. So this statement is generated again automatically, and you just can copy and paste it here and hit and run. And what interesting thing is now, any application that you have downstream can now speak SQL, can connect to this and get almost in a real time using the latest model, getting the latest prediction. And again, that's one of the great benefit that a lot of our customers are getting. So because if you didn't have that transaction and this integration, many of our customers, what typically they had to do was pulling data around, running through the models and getting the scores and storing that results and scores in database back. So this back and forth will be removed completely. So you just directly hit anytime that you need predictions, you just call that, you're using SQL like this that we just saw, and run it and get the latest predictions. You don't need to wait, run the next batch of scoring maybe next week. You don't need to wait for that. Okay, what we've done here is just build a model and deploying SageMaker, but obviously there are a variety of tools that we can connect in AWS. And again, the way that I want, we need to do, go to eScorer, see that I know what we need to do, what we need, what kind of commands, and then we can do the integration. And one of the things that I like to mention here is the great thing about SageMaker is that it's already very well connected to the rest of AWS ecosystem. So for any other AWS tools that you need to connect to H2O's model, again, eScorer can generate for you all simple examples for that specific model. and simply run that through all the application and ecosystem here and connect to and get this inference that you need, and with any preferred ways that you have. Okay, now we're back to the we're getting close to the end. And one question that we need to obviously answer is that what is the business value of doing all this, steps? And we need why again we need to care, and what is the ROI of doing these steps and bringing machine learning model for fraud detection. This specific customer that I explained, these sort of models that we built for them, they have reported they have been able to reduce false positive by 64%. And if you look at, if you recall from the presentation that we discussed about, where is the huge, costs is, or the savings can be gained, is actually from false positive. So these amount of reduction false positive is actually huge, and you can imagine what savings could be for them. And also the fraud itself has been reduced by 50% using these models. So today we talked mainly about fraud, but many of the techniques discussed today are applicable to similar use cases in various business lines, in case you have other cases and interest in. The final word before we close the session, I'd like to cover one thing, and that says that we all have seen the emergence of generative AI and GPT models has opened up numerous opportunities to solve some additional business problems, right? So I wanted to give heads up that our next section with AWS will cover some of the work that we've been doing with our customers in this space. I'll go a bit quickly through this due to limited time, but what I want to mention that things that are going to be covered are around interacting with document like RAG system that you're already most probably familiar with. And one of the topics that will be covered is multi-modality, because it's really crucial in for financial documents, due to you have typically various objects in documents, like text, that you're going to have charts and things like this that is not as straightforward as text to analyze. And obviously, in regulated industry, we need to be very, very mindful of privacy and regulation requirements. So that topic and things like API reduction would be will be covered. And another interesting use case in that domain is document analysis in terms of changes. So I'm not talking about what text has changed, but what is the implication of that change in terms of risk and legal compliance and so on and so forth. So actually, that was all I wanted to cover for today. I appreciate your time, and we invite you to use the links below to get in touch with us if you have any questions, or if you'd like to discuss about some of the points that we have addressed today. I don't know if there is any questions, and if time allows, yeah, we might be able to answer some of this. Okay, great.
Yeah, we do have a question that came in. How much time savings and productivity have you seen from your customers with this integration with AWS?
So it's really difficult to answer, because it varies a lot depending different organizations. But typically, if you're talking about, because that's a really good question, because it has multiple aspects. One is the technical, one is the internal review process and model approval. They have been able to increase the or reduce time to production with a huge range. In some organizations, we have been able to, at least technically, to reduce months of model building, and sometimes even a year, because of a variety of different things. Like every time that you create a new feature, you need explanation that has been done manually, and all that has been done in a few weeks. So in a few weeks, you can build a model and deploy it. And the other aspect, obviously, is approval process. That's also was interesting, because as we have seen in this webinar, this automating, creating documents is immensely help the model approval process, because those that go for approval process, they're very familiar after 1 or 2 times that you do, they become very familiar with these type of documents. So they get exactly information that they need from the documents. It's not human written, so that every time is different. So they know the structure, and they can also change it according to the internal review process. So we get improvement from 2 perspectives: like technical building models, because that really streamlines feature engineering model building, and from a couple of months again or year again, we are reducing to weeks. And the model building itself is perhaps around a few hours. So if you hit the experiment, you get the model done in a few hours. But you need obviously a few days to look at it from data science point of view, and then send it for review, etc. But anyway, if it was a long response, but it depends. But we see again from years, months to weeks.
Okay, great. Also, Art, this question is for you. Can you share some insights on your perspective about the integration with AWS and H2O?
Sure. Thanks for that question. As you saw in one of the earlier slides, AWS covers the entire stack of Gen AI, everything from custom silicon to obviously a number of different EC2 instances, management plane, and various managed services that are powered by different toolings and frameworks. H2O.ai has been able to have a level of integration from a custom silicon perspective all the way to integrating with various managed services of AWS. So we see, and we see most in their ability to integrate with different services as their ability to target or be able to target different use cases. I mean, we saw financial services today, but that's just one of potentially many use cases that can be addressed by H2O's integration with AWS.
Awesome, thank you. If anybody has any additional questions, please feel free to reach out. We have the email addresses up, and we're going to be sending out a recording via email with some links, and we'll also include Art and Ashgar's contact information in case you guys have any additional questions. But thank you so much for joining us. We certainly appreciate it. I hope you found this beneficial, and we look forward to seeing you at the next one. Thank you all. Have a great day.
Thank you.
Thank you.
Bye.